Hi, everyone. I'm Karthik Ramesh here from NXP. So we'd like to introduce Zendar's new technology here. ADAS is a evolving field with a lot of new things happening every day. But better sensors are going to make ADAS better in the future. And Zendar has really cool technology out there, and we would like to talk a bit about that in this next 5 minutes.
Thanks, Karthik. All right, hello, Startup Autobahn. So this presentation is called Breaking the Radar Ceiling, and I'll get to that in a second, why it is. But first, I want to say radar is the optimal sensor to pair with camera. When you look at it against LiDAR and camera itself, we get many advantages. One is range. We get to see further. The other one is it works in any weather, any and all weather. It's low cost, and it comes with natural velocity estimation. Now, the one problem is resolution. It doesn't have the same resolution quality in its current form that LiDAR does. And that's why lots of companies will choose LiDAR. We're changing that at Zendar. So let's talk about why we need to improve in terms of resolution, right? So imagine this scenario. Cars moving at 130 kilometers per hour on the highway. You're going to need about 3.7 seconds to stop that car. Now, if you can only see 25 meters, that's not enough time. If you can see 115 meters, that's not enough time. Those two first statistics, the first one, 2.5 degree resolution, that's the radars in cars today. 0.5 degree resolution, that's the radars in cars 2027. Now what we're doing at Zendar is we're bringing that resolution number down to 0.25. And that's going to give us ample time to actually see what's going on in the scene and react to it. Now, how do we improve radar resolution, right? Zendar has one approach, but the industry standard has been for a long time to make bigger and bigger sensors. That can only get you so far. You can only make such a big sensor and put it on a car. Otherwise, it's impractical. So we have an aperture-centric radar design, and that means that we focus on increasing the aperture, and we don't necessarily care about the size of the sensor, right? Except for that we care that it's small, so it's cheap. So an aperture-centric radar design is the ability to increase the aperture without increasing the size. We do that in software purely. So spatially separated radars together form a larger sensing surface if you can operate them coherently as one. That's what Zendar software enables. Long-range, high-resolution sensing at a low cost. Those radars that we use on the edge here, NXP makes them, other Tier 1 suppliers make them, they're cheap, they've been in production for a long time, they're great. Our software runs on a radar processing unit or in the central compute. It's great. It's not going to take a ton of your compute power, and you get high resolution of an imaging radar, but at a much lower cost. Now, I want to focus on something. This is not a theoretical kind of project. This is a real project. We've been working for a long time on it. And what you see on the right is plots from a single sensor medium range radar sensor and a distributed aperture radar sensor system. If you see on the right, you stop seeing the pedestrian at 150 meters. Look at DAR, we go beyond 300 meters. We're able to see a lot further. Apply that to the highway, you get a much more capable ADAS system. I'm going to skip this for ease and time. But effectively, you can find this on our LinkedIn. It shows resolution in action. And finally, to conclude, the industry approach so far has been to design smart radars. They're very highly capable. Processing is on the radar itself. They do really well, but it only takes you so far. So what we do is we take multiple different sensors, fuse them together at a much lower cost for even better performance in terms of resolution. That's distributed aperture radar from Zendar in partnership with NXP. Thank you, guys. Find out more, zendar.io.